So here we're going to get some practice just doing some mixed problems. We're going to do a few slides like this where they're just all mixed up, and we're going to have to figure out what kind of equation we have and what's the best technique to use to solve it. Okay, so we're going to solve, there are two on this slide, we're going to solve the following equations. The first one is the square root of x plus 2 plus 4 equal to x. All right. So I look at this and I see the square root there, and I immediately think, okay, I have to get the square root by itself because my goal is going to be to take the square root of both sides. I don't want to do it right away though, because then I'd have to FOIL out the square root of x plus 2 plus 4, right? I'd have that squared. So the first thing I want to do is to subtract 4 from both sides. So I've got square root of x plus 2 plus 4 minus 4 equal to x minus 4. Okay, so that will leave the square root of x plus 2 equal to x minus 4. Okay, now to get rid of the square root, I have to square both sides. Yeah? So that on the left will leave x plus 2, right? Because squaring a square root undoes the root. And on the right-hand side, remember with the x minus 4 quantity squared, that is a perfect square trinomial, right? So if you remember the formula for that, we can totally use that. You can also just FOIL it if you don't remember those things. All right, so if we FOIL this, I'm going to have x times x is x squared, x times negative 4 is minus 4x, minus 4x in the middle there. And in our last term, negative 4 times negative 4 is positive 16. Okay, so I'm going to have x plus 2 equal to x squared minus 8x, right? Negative 4x minus 4x is minus 8x plus 16. Okay, so now I look at this and I have a quadratic equation, right, with that x squared term. So what I want to do is to get the x plus 2 that's on the left-hand side there over to the right. I want to subtract x and subtract 2 from both sides, right? Because anytime you have a quadratic, the first thing you want to do is set it equal to 0, yeah? So I've got x minus x plus 2 minus 2 equal to x squared minus 8x plus 16 minus x minus 2, right? I'm subtracting x and subtracting 2. Hopefully that's not too confusing, doing the two steps at once. But I've got x squared. Now 8x minus x is minus 9x, right? And 16 minus 2 is 14, so I have plus 14. Okay, so now I have this set equal to 0. 0 equal to x squared minus 9x plus 14. Okay, now 14 is not a perfect square. My leading coefficient is 1, so that's helpful. So I'm looking for factors of 14 that add to negative 9. Okay, well in the times table I'm thinking about 7 and 2, right? 2 times 7 is 14. And to get negative 9, both of my factoring numbers have to be negative, right? So I would have negative 2 minus 7. That would give me the negative 9, right? And negative 2 times negative 7 is positive 14. Okay, so when I factor this, I'll have x minus 2, right, times the quantity x minus 7. All right, now I have to use the zero product principle. So I'm going to have x minus 2 equal to 0, or x minus 7 equal to 0. So in the first one, I'm going to add 2 to both sides. 0 plus 2. And that will leave x equal to 2. And over in the second one, I'm going to add 7 to both sides, right? Plus 7 and 0 plus 7, and I'll end up with x equal to 7. Okay, so I have two solutions, x equal 2 and x equals 7, and it's always a good idea to check. And any of these equations, it's a good idea to check. Sometimes with some of these types of equations, you can get extraneous solutions where you didn't do anything wrong algebraically, but maybe the thing doesn't work. So let's just check them just for good measure. So with x equal to 2, I'm going to have the square root of 2 plus 2 plus 4, plus 4 outside the radical there. And is that equal to 2? Well, I've got 2 plus 2 is square root of 4. Square root of 4 is 2. 2 plus 4 is not equal to 2. Okay, so that does not work. Let's try 7. I've got 7 plus 2 inside the radical and plus 4. Is that equal to 7? 7 and 2 is 9, right? Square root of 9 plus 4. Is that equal to 7? So I've got 3 plus 4 equals 7. It does, right? So the solution set is just 7, right? So in this equation, this is a classic example of why you always want to check, right? Because we got a solution. We didn't do anything algebraically incorrectly, but we got what's called an extraneous solution, okay? So when we plug it back into the original equation, it doesn't actually produce a true statement. So you always want to check and make sure. Okay, so in this next example, I have 7 times the quantity y minus 3 equal to 2 times the quantity y minus 9 plus 2y. Okay, so I'm looking at this and I see a bunch of parentheses, right? I don't see any exponents higher than 1. So it strikes me as being linear, but that'll show itself even more as we get going. So the first thing I want to do here is to eliminate the parentheses. So do the distribution. I'm going to distribute 7 through the y minus 3. So I'll have 7y minus 7 times negative 3 is minus 21, right? And then over here on the right-hand side, I'll have 2y, right? And 2 times negative 9 is minus 18, plus 2y, okay? Now, over on the right-hand side, I'm going to combine like terms. So let's see, I'll have 7y minus 21 equal to 2y, and 2y is 4y minus 18. Now, you can do 2 steps at once if you want, if you're really that good. I'm going to do 1 step at a time here. I'm going to get y over on the left-hand side and all the other stuff over on the right. So the first thing I want to do is subtract 4y from both sides. Okay, so I'm going to have 7y minus 4y minus 21 equal to 4y minus 4y minus 18. Okay, so on the left, I'm going to have 7y minus 4y, which is 3y, minus 21, equal to negative 18. I want to add 21 to both sides, right? So I'm going to have 3y minus 21 plus 21 equal to negative 18 minus plus 21. Okay, so on the left, I'm going to have 3y. And on the right, negative 18 plus 21 is positive 3. So now I'm going to divide both sides by 3 to get y by itself. And y is equal to 1, right? 3 over 3 is 1. Okay, so let's check that. I'm going to stick 1 in everywhere I see a y in the original equation. So I'm going to have 7 times 1 minus 3 equal to 2 times 1 minus 9 plus 2 times 1. Is that a true statement? Let's see here. 1 minus 3 is negative 2. 1 minus 9 is negative 8. And then we're going to have plus 2. Okay, so 7 times negative 2 is negative 14. 2 times negative 8 is negative 16. Plus 2 is negative 16 plus 2, negative 14. It is. So the solution set is 1. Okay, so this was a good review of how to solve a radical equation and also how to solve a linear equation, right?